Hi guys, welcome to a new video on differentiation paper 2 under math studies. In this video I shall tackle the two problems on the screen. They are of an upper intermediate level difficulty, a level 4 difficulty, and they deal particularly with some coordinate geometry concepts that are not present in other questions. I shall begin the first question shortly. I shall now attempt to solve May 2013, time zone 1, question 4. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So in question A, you are required to calculate f of 1. This is done by plugging 1 into f of x, into these two x's right there, and you find the answer. So 14 over 1 plus 1 minus 6, and this gives you 9. So in B, I'm required to find f dash of x. I've rewritten 14 over x as 14x to the power of negative 1 to help me with the differentiation. So this shall be negative 14x to the power of negative 2, and the x becomes a 1. You can also rewrite the derivative expression as negative 14 over x squared plus 1. So the green and the purple expressions are both correct. So in C, I'm required to use my answer to part B to show that the x coordinate of the local minimum is 3.7. So there is a calculator function that can get you the coordinates of the local minimum, but you cannot use it in question C because you are told explicitly use your answer to B. So you have to demonstrate an understanding that the minimum point is obtained by setting f dash of x to 0. The slope has to be 0, so f dash equals 0. So that's what we shall do. I set this purple expression to 0, and you have to do some algebra. I took the fraction to the right hand side and changed the sign. I multiplied by x squared, getting this expression. Hence x equals root 14, which is 3.7. You get marks for this workout, even though the calculator can get you this final number in a second. But you have to do the workout to get the marks for C. In D, I need to find the range of f. So the range of f extends from the minimum vertical height to the maximum vertical height. So we know that there is a minimum point right there. So the y value of this minimum point shall be the minimum value of y. So I need to get that. And then the maximum value of y is the y value at point A. And point A is the first point on the curve. So since this is the first point, this is the point where x equals 1. So I need to get the y value of the point where x equals 1. And this has already been obtained in A, f of 1. So the value of f of 1 is the maximum y value. And the y coordinate of the minimum point is the minimum y value. So I've written the equation down on the GDC, and I've adjusted my window, putting the x as they have stated, and you can just play around with the y a bit. Next, you click on trace. There is your function. Second, trace minimum. A left bound and a right bound. So I'm going to space them a little bit here just to make sure that I cover the entire range of the minimum, because the curve, as you can see, does not have a clear minimum point. There is my guess. So the calculator tells me that the minimum point exists at x equals 3.74, which is what I got, and y equals 1.48. So these are the coordinates of the local minimum point. So the minimum value of y is 1.48, and the maximum value is the value we got in question A, which is f of 1, which is 9, because as you noted, this was the highest point in the curve. Hence the range extends from 1.48 up until 9. Excuse me. So this was supposed to be y and not x. This was a mistake. Excuse me. We are then told points A and B lie on the graph of f. The x coordinates of A and B are 1 and 7 respectively. They exist at either end of the domain. Write down the y coordinate of B. So I just need to find the y value when x equals 7. You just click on second, trace, value, and 7. And the y value is 3. Next, I want the gradient of the straight line passing through A and B. So this is a simple slope formula. So A has coordinates 1 and 9, which we already got. B has coordinates 7 and 3, which we got from E. So the slope is 3 minus 9 over 7 minus 1, which is negative 1. Next, I want to find the coordinates of M, which is the midpoint of line segment AB. So the midpoint is obtained by averaging the x values. So 1 plus 7 over 2 gives me 4. 8 over 2 gives me 4. And similarly for the y values, 9 plus 3 over 2. So 12 over 2, which is 6. These are the coordinates of the midpoint. Next, you are told that L is tangent to the graph at the point with the same x coordinate as M. So let's try to visualize this. There is a line joining points A and B as follows. There is a point somewhere in the middle, which is M, and we are then told that L is tangent to the curve at the point that has the same x coordinate. So it exists right below point M. So the tangent line exists somewhere around here. This is our L. We need to find the gradient and then the equation of L. So this depends on my knowing the x coordinate. In order to find the gradient of the tangent, I shall simply plug the x coordinate into f dash of x, and this shall get me the gradient. Then in order to find the equation of L, I need the gradient and the point. I've already obtained the gradient before, so I just need the point, and this is obtained by plugging the x into the original equation of the curve in order to get the y value. So let's say this again really quickly. I want the gradient of the tangent, so I shall simply substitute the x coordinate into f dash. This is how you get the gradient. To get the equation, I need the gradient and the point. So to get the point, I shall plug the same x coordinate into the original function to get the y. So since the x coordinate is 4, then the gradient when x equals 4 is second trace, find gradient for 0.124999, so just 0.125. This is your gradient. To get the equation, you need point and slope, so we said we'll plug the 4 into the original function to get the value of y. So second trace value 4 and y is 1.5. So use the point slope formula with the values of y and the slope and the x. Then you expand, and there is your final answer, and we are done. So the next question that we shall solve came in May 2013, time zone 2, question number 5. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given this function y equals negative x squared over 10 plus 27 over 2 in the domain x greater than 0 and the range y greater than 0. And in A you are told that the coordinates of point A are 75 and 450. Determine whether point A is on the track or not, giving a reason for your answer. So if point A is on the track, then it must satisfy the equation of the track. So when x is 75, y has to be 450. So I shall plug 75 into the x and determine whether or not y is in fact 450. So I can plot my function on the GDC, writing this equation down and using the window 0 to 500 in y and 0 to 120 in x, and then plug the value of x into the function to see whether y is correct or not. So there is my function. I've written down the function on the GDC. There is my window according to the information provided in the drawing, and there is the graph. I want to find the value of y when x equals 75, so I shall click on second, trace value, and x equals 75. And the calculator tells me that when x is 75, y is 450. Hence, the point 75, 450 lies on the track. Next, I'm required to find the derivative of the expression. So negative x squared becomes negative 2x, and of course the denominator remains as it is. 27 over 2x becomes 27 over 2. So this is your derivative function. I can simplify 2 over 10 right there, and it becomes just x over 5. In question C, I am told use the answers in part B to determine if A is the point furthest north on the track between O and B or not. Give a reason for your answer. So the point furthest north is the highest point on the track, or the maximum point on the curve in our terminology. So I just want to determine if this is the maximum or not. I cannot use the GDC to do so because I was explicitly told use the answer in part B. So we should know that the derivative function is set to 0 in order to find the maximum point. The maximum point exists when y dash equals 0. So I shall set the expression that I obtained in B to 0 and solve. So the algebraic way to do this is to multiply everything by the highest common denominator. So 10, the 10 shall cancel both denominators, and you shall get this equation, and x equals 135 over 2. So since the x coordinate of the maximum point is 135/2, then point A is not the maximum point because it has an x coordinate of 75. So this is not the maximum point. In DI, I'm required to write down the midpoint of line segment OB. So there is your O, the origin, and there is your B, and you have the coordinates for B. So this is simple. There are your 2 points, hence the midpoint is obtained by averaging the x's, 0 and 100. 0 plus 100/2 is 50, and for the y, 0 plus 350/2 gives you 175. Next, you are required to find the gradient of the line segment OB. So again, using the 2 points. So y2 minus y1 over x2 minus x1 gives you 3.5. Next, you are told that Scott starts from a point C, 0 and 150, so somewhere around here, and he bikes along a straight road towards the bicycle track parallel to the line segment OB. So there is your line segment OB, and he bikes from this point in a line that is roughly parallel to this line. So you are required to find the equation of his road, the equation of this line, and then in F you are required to use the GDC to find the coordinates of the point where Scott first crosses the bicycle track, which is this point right there. So we need to get the equation of Scott's line and then use the GDC to find the point of intersection. To get the equation of the line, we need a point and a slope. We already have the point 0, 150, and since the line is parallel to OB, so it has the same slope or the same gradient which we already obtained in DII. So we have everything we need for the equation. So the gradient is the same as what we obtained before, and the point is 0, 150. Hence you plug into the point slope formula, and this is what your final equation should look like according to the format that they asked for in the question. Finally, in order to determine the point of intersection between Scott's road and the graph, I need to rewrite this equation in a way that I can put onto my GDC. So there it is, y equals mx plus c. So let's plug this onto the GDC. There is my equation similar to the green equation in F. And I want the point where he first crosses the track, so I want this point of intersection. So second trace intersect. There is your first curve. There is your second curve. And your guess is roughly here. So the point has coordinates 18.377 or 18.4 or 18.38, and y equals 214.32. This concludes our question. Take a minute to copy this down if you will. I hope you found this useful.